Hi guys, Dr. B here. This is a lecture detailing the different types of chemical reactions you're going to be expected to know how to do and be able to know how to recognize. So the different types, there are several names. For example, combination, synthesis, and composition, that describes the same thing. Decomposition, single displacement or single replacement, double displacement or replacement, and then combustion. There's mainly 5 types, but there's different names for some of them, so you need to be able to recognize these. So combination or synthesis or composition, 2 or more reactants form one product. So 2 or more reactants, one product. So here are some examples. Reaction of sodium, Na plus chlorine makes sodium chloride, Na plus Cl1 minus. So this is technically NaCl. If you see chlorine by itself, it's diatomic, so Cl2. To balance this is going to be 2 NaCls, 2 Nas, and 1 Cl2. The burning of coal to give off carbon dioxide. So when you're burning something, that terminology of burning, you're actually taking the oxygen in the air and adding it to the substance, because the oxygen in the air is ignited, so to speak, by some energy, and then you add those together. So you have carbon, it's not diatomic, plus oxygen, O2, makes CO2, carbon dioxide. That's where the name comes from. So to balance this, it is 1, 1, 1. Decomposition, you have a single compound breaking down into multiple substances, multiple products. So decomposition, think about from biology, if something is decomposing, it's breaking down. So you have water, H2O, breaking down into hydrogen and oxygen gases. So this is H2 plus O2. So 2, 2, 1. Decomposition of hydrogen peroxide, that's H2O2, forming oxygen gas, O2, and water. So hydrogen peroxide is a thing in the brown bottle that you see in stores, and sometimes you may use it in first aid to clean a wound, or even it can be used to actually get rid of blood stains and all that type of stuff. So what happens when you see the foaming and bubbling, that's actually oxygen is being formed, and then the water is kind of like the watery substance, liquidy substance. So that is the hydrogen peroxide decomposing, because your body has an enzyme called catalase that can be used to break down hydrogen peroxide. So this is 2, 2, 1. So a single replacement or single displacement. One thing kicks out another element. So we have zinc metal being placed in something of copper 2 sulfate. So Cu 2 plus SO4 2 minus CuSO4. When you crisscross, the zinc will come along and kick off the copper, and it will take its place. So you end up with zinc 2 plus SO4 2 minus. So the compound is zinc SO4 plus Cu. And luckily for us, when we balance this, it's just 1, 1, 1, and 1. So a single displacement reaction comes in and kicks off another element or displaces it. Double displacement or double replacement. So in a single replacement reaction or displacement, we have one chemical species being kicked out. In a double or metathesis reaction, you have 2 things that are switching places. So most of the time, it's either going to be, you're going to either form a precipitate in a precipitation reaction or water in a neutralization reaction. So a precipitate is an insoluble solid. That means it cannot be mixed in. So it's not really the same thing, but the general idea is when you're adding like chocolate powder to milk or protein to milk or water, and you shake it up and try to mix it, and you try to shake it as much as you can, but some of it does not just dissolve. It does not mix with the water or the milk, and you're kind of left with a solid leftover residue. That's the part that cannot be mixed in. That's insoluble. So a precipitation reaction. So this is an example. Remember, two things are switching places. So we have potassium chloride, K plus, Cl1 minus, so KCl. We have silver nitrate, that's Ag1 plus, NO3 minus. Those crisscross is AgNO3. And I'm going to tell you that you are going to make something. You're going to make an insoluble solid because it doesn't mix through. Right now, you don't need to be able to recognize that from the reaction, but if you were to be in AP chemistry, that is something you need to know. So let's keep the cations in the same place and just switch the other things. So NO3 and Cl. So you end up with KNO3 and AgCl. And luckily for us, these are all ones for our coefficients. So remember, a precipitation reaction is a type of double displacement reaction where you will make an insoluble solid, or that precipitate. The second type of double displacement reaction is a neutralization reaction. So when we hear the word neutralize, that means to kind of make ineffective, or to take care of, or to kind of calm down. So in this type of reaction, we have, it's still double displacement, but we have an acid and a base. They react together to form a salt and water. When I say salt, I just don't mean, you got to stop thinking of just NaCl. When I say a salt, that means it's the ionic compound, but the solid form. If I say table salt, that's sodium chloride. So we have an acid, and it tells you sulfuric acid, and I will say that it is H2SO4 plus my base sodium hydroxide, NaOH. So I'm going to form water and the salt. So you'll notice here I have my H and Na. Then I have my SO4 and OH. So I'm going to keep my things that I circled in the same place. But then I will switch the ones that I underlined, can't really see, so SO4, 2 minus, and OH. This makes water over here and sodium sulfate. Okay, then you balance this. I have 2 NAs here, so I'll put a 2 here. I have 4 H's, so I'm going to put a 2 over here, and I'm balanced. So notice I'm going through this kind of quickly. It's because you should be able to do this quickly as well. The last reaction is a combustion reaction. So it's usually a hydrocarbon compound. Oops, shouldn't have done that. A hydrocarbon, which is a compound containing mainly carbon and hydrogen, sometimes oxygen as well. It reacts with the oxygen in the air. There's a spark and energy, that flame ignition that allows the oxygen to add to the hydrocarbon, and you end up burning stuff. So heat is one of the byproducts of this, but the main products to think about when you're doing your reaction is the following. So you have C3H8 propane plus oxygen in the air. So you've seen these reactions, you end up producing CO2 and water. These are the two products you're going to get, plus heat, but you don't really account for that in your actual reaction, your equation. So to balance, 3 C's, 4 H2s right here. So then I'll put a 5 up there for 10, you have 1. All right, so that's the 5 types of reactions you need to be able to recognize. If you have any questions, please let me know. Thanks.